Welcome back, everyone. Today's gonna be really fun because I'm building some picnic table frames right here on the Fireball table. And I thought this was a perfect time to give you an introduction into how the table works and maybe even how to do some fixturing if you've never done this type of work before. So this is what I have to build. We're gonna be building it out of 3x3 square tubing, and I'm gonna be building it in sections. It's gonna include 2 sides and then we'll marry them together. But I'm gonna take the opportunity to put it on the fixture table because I got like 8 of these things to do. So it's gonna be worthy of taking the extra time to put the fixture together. This looks pretty intimidating, doesn't it? And it looks like chaos, but I assure you every fixture is in a specific place for a reason. And I think there's a lot of education there to show you guys why and what I did this for. So let's strip it down and start over. The first thing I'm gonna do is take all the clamps off. I think it's much better for you guys to see where I'm going, to be able to follow along as we're building. We'll come back to these in a minute. All right, now time to pull all the material out. Let's take everything off the table, put it back into the bin. We're gonna start from scratch. This is just WD-40. Kind of cleans the surface a little bit, make sure there's no high spots. I can feel it with a rag if it were to catch on a BB. Now that we have a clean table, it's time to get started. And it starts actually right here. In order for fixturing to go smoothly, you're gonna need to have a set of drawings that have been dimensioned properly. And what I mean by that is I like to work left to right, just like how you read. And I give myself a 0, 0, an X and Y coordinate dimension system. What we're seeing here is where the tubes go, but this is also telling me where my fixtures need to go to set up a stop. The whole idea of this whole fixturing plan is to eliminate errors. And what I mean by that is, what happens if this tube length is too short or too long? I want my fixture to tell me that there's something wrong with my material. Or vice versa, if this tube needs to be centered, I need to make sure that this tube is actually in the center. And find hard points, which means what are the critical dimensions? In this application, it's the seat height. So that is a critical dimension. The height of the table is a critical dimension, the widths, and all the above. So that's what I'm looking for, and we'll talk about those as we go along. All right, the first thing that we need to do is set up our grid line. Because I like to work left to right, I'm gonna give myself a 0 going up and a Y going across. Basically, we're gonna be starting on these 2 corners. I'm gonna start with the fence block. This is just a 2-pin system. There's no ball lock bolts. It's just basically a fence. And my material is gonna butt up in here, and this edge is gonna be my 0, 0. So let's call this spot right here 0, 0. I'm gonna go along up the row. I know I have to be at least 16.5 inches tall. So I'm just gonna grab my tape measure, know that I'm at 16.5 inches tall. So I'm gonna put another one right here. Okay, these are hard points. These cannot change. Now let's go along the Y and do the same thing. I'm gonna continue with the fence blocks, and I'm gonna go out just under 63 inches. So I just pull a tape measure. This is just for reference. That looks pretty clean. Maybe one more in the center. Now these fence blocks have pins that are offset, so I can I can pick which direction they're pointing. It gives me a 1/2 inch offset to flip directions. There, we have our 2 starting points. Everything from here on out needs to be adjustable, which means I can't drop in a pin or a fence block, and it's gonna be in the correct location. No matter where hole it is, this will not work for me. So we're gonna have to build in adjustability as we build out. And we're gonna do that with this. This is what I call the tooth block, and it has a riser attached to it. And I can configure this tool in just about any way I want. I can put a whole bunch of different attachments on it. And in this case, I have a 6-inch riser attached to the tooth block. And we'll put one together right now. So this is the base, this is the riser. And I can put tall riser, short riser, side fence. I can do whatever I want with it. But in this application, this is gonna be perfect. I'm gonna need a whole bunch of these. So let's screw this together. Because this is a modular system, I get to pick how I want my fixtures configured. And this is probably my go-to size. I like these 6 inchers, and I'll show you why in a little bit. But because we're working with 3-inch tubing, I need something that has quite a bit of height here. From here on out, we're using tooth blocks with 6-inch risers attached to them. And I'm gonna look at my drawings, and it says 63 inches from 0, 0. That is the end of this riser where you put your seat on. So all I'm gonna do is just measure out to 63 inches. And I'm gonna do that from this fence block that's already now my 0, 0. 63 puts me right here. Now, this is a slot. As you can see, when I put my bolt in the hole, this is the pin that holds the fixture down to the table. And I call these tack bolts, and they have a ball that swells out on the end that grabs the bottom of the table, and then this part pinches the part down. So there's pinching action between this ball and this shoulder. And this allows me not to have to put a nut or anything on the bottom side of the table. So when that goes into the hole, all I need to do is turn the knob and that ball swells out, grips, and that's it. That's all the tighter you need to go. But this is a special tool, which means it slides. So now I need to figure out where it goes. So theoretically, this needs to be at 63 inches. 63 inches puts me right here. And now it's up to my tape measure. I have now a $10,000 table and I'm still using a tape measure. This is kind of ridiculous. This could be off. So I want to eliminate some error, but this tool has a special feature on the bottom and this will take the guesswork out of it. This is a tooth grid pattern and these are in 1/8 of an inch increments. I'm going to add this washer to the bottom and it goes underneath, and then this bolt goes through both the washer and the fixture. And what this essentially does is that it locks this fixture in place and I can't slide it back and forth, but it also sets my measurement perfect. So let's pull the tape measure again. What did I need to be? 63 inches to the outside. So I'm gonna jump this over to 63. Looks like I just was off by 1 tooth here, but there. And now the table has set my dimension for me, not my tape measure. This cannot slide, but this tooth block can still rotate, which means pivot on that pin. So I need to lock that axis in position, and I'm going to do that with this locating pin. It just drops right in the hole, just like that. Now it can't twist. So that one is now set. We've created a box now, our outside parameters of our tubing. So you're probably wondering, why did I start out here on the end? I like to start on the far outside and work my way back into 0 so that I can use my tape measure as reference and not have any obstacles in my way. So let's take a look at the next piece of material, and that's this vertical riser. And from 0, 0, we're at 33 inches to the outside of the tube. So let's do the same exact thing with the tooth block. Okay, so I'm at 35, I need to move it to 33. I'm gonna slide it right to there. Chunk, just confirm with my tape measure. Yep, exactly 33 inches. No guessing, no sliding. Now here comes the magic. I know that I want another one of these tooth blocks right up here. This is going to allow this piece of tubing not to twist if I put another fixture up here. So let's put another one there. I could measure from that block again over. That's one way to do it. Just keep pulling off of the 0 reference. But another faster way to do it is to actually just look at this fixture. And I can see where I'm at. I'm all the way to the back here on the slot. So I can just set this one at the same spot. Now I've matched and I didn't even have to pull a measurement. So setting up 2 in line with each other is extremely fast and easy. This is why I just love this tooth system. There we go, we got our vertical tube set up at the correct dimension. Now let's go up to the top. Now I like to use a fixturing motto that fixture on the fillet, which means if there's a fillet weld inside, I want to make sure that my fixture is also on the inside. This is going to reduce distortion. As soon as you put a fillet weld inside, these 2 ends of this part are going to want to bend down in a U shape, or it's going to make an umbrella basically. But yeah, a fillet weld fixture. I like to put my pins in and then move the clamp to where it goes. That's just my methodology. So we need to be 28 inches. So as you can tell, I don't have a block here, but I can always just move this one over if I wanted to actually have a measurement. 28, so I need to be way up here. I was way off, but that's okay. I'll just set it up here. Dead on every time. How fast is that? No slots to mess with. Oh, that is so cool. And once again, I need to have this same exact fixture on the opposite side. So we need to mirror it, and we're just gonna watch the scale and set the other one up. No need to pull a tape. I'm in this hole, and I'm at halfway point, which is one. I was off 1 jump. There we go. Look at that. No measurements necessary. Of course, you could always pull a tape measure just to confirm if you're really worried about that. 28, see, without trying. How slick is that? All right, we're doing good. We just have a couple more to place down. What we're working on now is this cross tube. I need to be able to constrain it. I know that I can't go forward or backwards with those two fixtures I just put into place, but now I need to locate it side to side to make sure that it can't shift side to side or my material is too long or too short. So we need to make sure that that can't happen. So let's put those two constraints there. And I'm gonna actually use these guys. This is the same tooth block, but I have a 90-degree fence on it. This is a movable fence. Where the ones we set up earlier are fixed, I can now position this one wherever I want, and this is just a stop. The plans call out for 11 inches from this surface to our 0 point. So if I want to, I could pull this over here, set this to 11 inches. 11 inches. And now we need to mirror this on the other side. I'm gonna put this in the same grid pattern, put my washer underneath. It's very systematic, I like that. And I know that my plans call for a 40-inch spacing between the two. And look at me, I'm way off, so we need to jump this forward up to here. There's 40 inches between the two. That's nice and handy, but I don't like the way this one is. I think I want to move this one over one hole. Now, can you imagine trying to dial in this dimension only to come find out you wanted to move it? That's okay. This is why this tool exists now, so that we don't have to be right the first time. We're in the same spot as we were before. Nice, I like that. Now we got a perfect mirror. That looks amazing. That is looking really good. I know it still looks like chaos, but we're getting somewhere. So now let's take a look at the plans again. I want to look at where the seat mounts. The seat mount has given me a 16.5 distance from 0 to the top of the seat. This must be a critical dimension because it's, well, dimensioned. So I want to make sure that this height is exact. Oh, I'm off a 1/16 or 1/8 of an inch. Need to move back one tooth. Dial that sucker in, 16.5. Let's quickly mirror it on the other side. And once again, I just need to look at the scale and I'm right on the halfway mark. Boom. Now we're matched to the other side. All my hard stops are now into place. Now the next thing is to get ready for actually installing the material. I like to weld with my work elevated off the table, something about 1 inch. So I'm gonna use the magnetic 1, 2, 3 blocks to be able to do that for me. So everywhere where a piece of material is gonna rest, I'm gonna put a block down. And I like magnet down. This is gonna allow me to weld without running into the table. If there's any variations in the tubing, if there's a high spot, low spot, this is gonna minimize that. And also wherever I put a down clamp, one of these need to be underneath of it so I don't bend the tube. So we're just gonna place them down around the table where I know where all the tubing is gonna go. And if you run out, that's okay, because all the fixtures are also 1 inch in thickness. So I can use the fence blocks, I can turn them to the side as a block or a shim, or these are 1 inch for that exact reason. So I'm gonna put it right there. I'm gonna put one right here. These are risers. And then I'm gonna put one right here in the center. And all the material will sit on top of it. So I made a little boo-boo. This is actually dimension 28 to the outside of the tube. And as you can see, my fixtures are set up 28 to the inside of the tube. So I just need to bump it back 3 inches. But because of the way the tooth block works, this is pretty fast. It's not a big deal. If I were to spend all this time dialing a regular slot in, this would be kind of a big mistake. So now 28 minus 3, move up. 25. So I need to set this to 25. That was fast. This one's still okay because it'll still hit the stop. Move this one backwards. Now I just pull it forward. There it goes. That's so slick. Spoils me rotten to have that feature. Okay, I think we're ready to put some material down. This doesn't look like pure chaos now, does it, when you actually have a system in place? So let's start adding material. All of these have already been cut. We'll talk about this here in a second. Something like that. Okay, now we got all the pieces fit in here. Look at that, it's all lined up the way it needs to go. All the measurements are set in place. It just boggles my mind how fast you could set this up. But really what I want to show you is how this setup right here is going to eliminate some problems. So let me show you some of the cool things that fixturing on a fixture table is more helpful than sometimes even using like the Fireball square in some instances. As you can see, when I cut this center tube, there's always variations. Did I cut it too long? Did I cut it too short? Did I cut it right on? Well, as of right now, look, it's actually too short. You can hear it. So, but now, typically I would just like butt the tube into one, bring it tight, butt this tube into this one, and now I've lost 1/8 of an inch overall, which in this application, who cares? It's just a picnic table. But if the plans call out for a specific dimension, there's no reason why you can't hit that. So this tells me that this tube is too short and I'm just gonna have to fill the small gap, which in this case, it's actually better for me anyway. The same with this tube. When going to cut this tube, if my miters are too long or too short, it's gonna allow me to either center it between the two if I want to keep it balanced and centered, or it just won't physically go in between the stops and I'm gonna have to shave something off. So that's just a real quick way to set centers by doing this, especially for repeatability. And then of course, this stop right here, this is the seat height. You're not gonna notice a difference if it's a 1/16 of an inch off either, but I know that that was a critical dimension and this is gonna allow me to hit that. And when back here, this is the weld joint. And if this joint was a little bit too long or too short, I can make this up. This is the part that sits on the ground. That's my float end. That's the dimension that was called out for, so that's what we gotta hit. So now that all the pieces are in position, now it's time to keep them there, and that's a whole nother challenge. So let's grab some clamps and we're gonna start holding them down. So this is a sliding clamp. It has a lot of adjustability up and down, and by looking at it, it's missing the other half. Well, actually the table is gonna become the other half by just inserting this pin into the hole. And by inserting the pin into the hole, and then applying some up force from this lever, it binds that peg and it will not come out of the hole by doing that. No matter how hard I try, the more force, the more bind. So then when you release the pressure, the clearance becomes there and it allows you to slide in and out. So we're gonna be placing these all over the table to hold in 2 axes. So if you look at the way this fixture set up, remember me selecting that 6-inch riser? I did this on purpose. For one, I want to hold this tube back tight up against the stop, because what's going to happen is when I go to weld, this thing could probably roll out. So knowing that it's probably going to want to pull right here on that fillet weld, I probably should put a stop here. So let's do that. It just so happens that this 3-inch tube steel fits perfectly in between another stop. What I mean by that is we've landed perfectly right on the grid. So I can put a stop right on the other side. See, now it's bound. Even when I weld right here, it can't move. Always have to have a fixture on the fillet. It's good practice. And then I want to hold it down. So I'm going to use this clamp to hold the tube down to the table. This is going to prevent rolling. And then one more clamp to hold it up against the stop. The reason why I chose the 6-inch riser was for this application. I'm going to use this hole like the table, and I'm going to put the clamp into the hole. And now I'm able to clamp this way, not straight down. Most 5/8 fixtures aren't strong enough to do this. So this is one of the reasons why I went with the 1-inch heavy-duty stuff. It's just for these exact reasons. Another thing to consider is welding. I know we're clamping everything down, but I've noticed that I don't like where this fixture is. It's right in my way of welding. I could weld in there, but this fixture is a little too close. But I'm just going to move it. So that's something also to remember when you're placing your fixtures is you still got to get in there to weld. Yeah, that's better. So let's apply the same application to this one, a down and an over. And also making sure the clamps stay out of your way, straight down. So as you can see here, fixture and fillet. So technically I should have a fixture here also. So let's add a couple more blocks. Okay, so now I know that won't move. And then this one, fixtures and fillets. So I've noticed when putting this tube in is that it's a little tight. So because this doesn't fit, this has showed me that this tube is too long, so I'm gonna need to shorten it a little bit. So let's take it to the grinder. Ooh, too tight. All right, let's try it again. Oh, that's much better. How slick is that? That was really helpful. Okay, let's put some clamps, hold her down. I like to put my clamps over the blocks that are underneath, and by doing that, that prevents the tube from bending. So when I put this clamp in, I didn't really think too far ahead. I'm gonna need to weld this fillet, and it's kind of in my way. I could still do it, but there's a better option. So I'm gonna pull this out. and I'm going to use this style. This is a quick release clamp with a swivel base on the bottom, and this allows me to drop that into the hole and then position the clamp in like a 2-inch radius per se. And this is going to work perfect for here because it's going to position the handle vertical and not sticking out right in my way. So by just rolling this down, I can put that clamp right in the center of the tube, adjust that, and click it in. And then this little fishtail allows me to really put an extra grip on it. And you can actually get this clamp tighter with this instead of the handle, believe it or not. There, I like that. Look how much cleaner that is without that clamp in the way. Now everything's pointed up. Slick. That looks good. I'll put these guys there. Same over here. Clunk. So there's a couple more clamping options. With the fence block over here, I can just grip the fence block and just put a clamp on it. That's the whole idea of it. It's to save you some clamps if you run out. I'll show you another option, is that we can take another one of these and you can reverse it. Because remember, we're trying to force it into the block. The direction of force is this way. So I can flip this around, flip the pusher. Now it's backwards, right? Now when I put it in the hole, see I could push with it. But see how what's happening here is that it's sliding because I don't have that washer in here. This is a problem. Or so you have to either bottom the slot out or you could put the tooth washer back in. So, but this time I've just bottomed out the slot, which is okay. I'm gonna push against the block, and that's another solution if you want a side push. And then here's another neat trick. So the tops of the fence blocks have these holes inside of them, and what that allows me to do is use one of these holes. If I'd like, use it on top. Maybe this, because this is pretty tall, this clamp won't reach that high. So just by going on top of the fence block, it can hold it down. Slick. Yeah, a couple more clamps, pusher clamps up against this one. Maybe a clamp just like that. And I think this thing's ready to weld. How cool is that? So hopefully this helps you with your fixturing and makes it simplified for you, and maybe inspires you to get a fixture table like this to help you speed up the process. But I like fixturing, and it's really fun to know that when I weld this thing, it's going to come out straight. And especially the next setup is going to be fast when dropping my components in here. But that was really fun, so thank you guys for watching, and I'll see you guys on the next one.